Polygons. First off, let's start with some naming of polygons. You can see right here, three sides of a polygon is a triangle, 4 is a quadrilateral, we also know as a square or rectangle, 5 is a pentagon, heptagon, hexagon, octagon, decagon, and so on, so on, so on. You can read those. These will be on your test, so you will need to memorize these basic ones right here. These, so 3 through 10 and then 12. That's right here. So this is 1, 2, 3, 4, and 5. That is a pentagon, so 5 sides of a pentagon. Octagon, so 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon. A heptagon has 1, 2, 3, 4, 5, 6, and 7. That would be a heptagon. Now, on the top, it also says a polygon is a figure with only straight edges, and number 2 is closed edges and no points on the interior. Closed edges and no points on the interior. This one, let's look at this one first. No points on the interior. This one is actually meaning each edge or each side can only touch 2 sides. That's what that refers to. So if we look at this one, let's look at the try and put these in order here. Let's look at A, B, C, and D, and E. Let's keep this in mind. Oops, too far. Well, let's look at A. Is A a polygon? Well, there's this side touches 2 sides. This line right here touches how many? Well, it touches 1, it touches 2, it touches 3, it touches 4, it touches 5, it touches 6. So this line right here makes sure that A is not a polygon because it touches interior sides, touches more than 2 sides. Let's look at B. So B, this looks good. There's a straight lines there and there and there. The only issue is these. So B, we're going to say is not a polygon because it has curved sides. Let's look at D. Straight side, straight side, straight side. Now, this issue right here, E is not going to be a polygon for a real simple reason. There's an open edge. Now that leaves C, which is a polygon, and D is a polygon. You can say, well, Mr. Locke, these are on the inside. Well, yes, they are on the inside, but this line right there only touches this one and that little small one right there. So this only touches 2 at each side. This one actually touches 6. So it's not really a polygon here, but yes and no. No and no. Now let's do another little example. Are these polygons? Well, are there any curved sides? No curved sides. Are there any open edges? No, there's no open edges. Does each segment only touch 2 other segments? Yes. So this is a polygon. Number 2, what do we see here? Well, we have curved lines, so that's going to be a no. Number 3, this is going to be a polygon because it fulfills all 3 of those rules as we talked about above. Now, convex and concave. Convex is a simple idea. It means that the polygon does not go in on itself. It sticks out. So we can say that these are all convex polygons. Now, if we want to talk about a concave polygon, we're going to talk about a polygon that goes in on itself. See, if we were to draw the side, connect it straight like this, like the dotted line right here, see how it goes in? This little part right there is where it caves in. That's so it's concave. So if we want to take a look at another one, we can say, well, let's look at this one. This would be concave too. Why? Because it falls in a couple spots right there, right here, and right here. So this is concave. So what's the difference between convex and concave? Convex, we can call it fat. Oops, not that one. Convex is fat. I don't like that. Convex is fat. Concave, small, falls in on itself. Corners are inside. Polygon. Now, let's take a look at these two. Are these two convex or concave? Well, first off, A is going to be convex, and this one is going to be a concave. Now, let's look at 4, 5, and 6. This one I'm going to suggest would be concave, or convex, I'm sorry. This one right here, we can see how it falls in right there. We're supposed to fill it out, and that would be concave. And this one would be right here, would be concave also. Now, next page. Equilateral. Now, equilateral means that all sides have the same length. Equiangular means that all angles are equal. And what do you think regular means? Well, regular means that both equilateral and equiangular. So sides and angles are equal. That's what that means. To give you another example, let's look down at, decide whether these are regular polygons. Too far. Okay, A. Well, looking at the markings, we can tell that A is a equilateral, but is not equiangular. So it is not a regular polygon. Looking at B, is equiangular, but not equilateral. So it is not a regular polygon. Whoa. Wow, that's a mess. I don't know what happened there. So it is not a regular polygon. The last one, whoa, not that either. This is a regular polygon, as you can see by the markings. All sides and angles are equal, so it is a regular polygon. Now, let's look at this one. 11, 12, 13. 13, well, we see the marking for the side, so this was going to be equilateral. We see the sides. Oh, this side and that side, those are not equilateral, but these angles are equiangular, so this would be equiangular. And this one, the sides are all the same and the angles are all the same. This would be regular. Okay. Now, is a polygon convex, concave, or is it regular? First off, name the polygon. So 1, 2, 3, 4. This is four-sided. Would be quadrilateral. Now, is it regular? No, it's not regular. So is it equilateral? No. Is it equiangular? No. Is it convex? Convex. All the sides are sticking out. Number 2, let's look at this way. Is it concave or convex? Well, if we connect this part up here, it's below that, so it would be concave. Is it regular? No, not all the sides are equal. Plus, the angles are not equal, so it's not equiangular, but how many sides? 1, 2, 3, 4, 5. This would be 5 sides. Pentagon. And this last one is a 1, 2, 3, 4, 5, 6, which is a hexagon. And then it is a regular, because all the sides and all the angles are equal. All right, so that's pretty much all I have today for you. Enjoy. Good luck.